Okay, so let's take a look at this example of 1 over 4 to the n. So this one, I think it's useful to write out the first few terms, write this as a sum with some dots in it, right? I think that often helps us to understand what's going on. So I'm going to write this as, okay, at n equals 0 we get 1. At n equals 1 we get a quarter. At n equals 2 we get 1 over 4 squared, and so on and so forth. And from this we see that in our formula c equals 1 and r equals a quarter, right? So we know how to plug this in to our into our formula that we have, and we just go ahead and do that, right? So this the ratio here, a quarter, is less than 1, so we're good, right? This absolute value of r is less than 1, so it converges. That's good. And then what we see is that then the series is going to be equal to right, we get 1 over 1 minus r, right? That's the formula we have using c equals 1. So there we get 1 over 1 minus 1 quarter. So that's 1 over 3 quarters. So that gives us 4 thirds. And boom, that's how we figured out the value of this geometric series. Let's take a look at our next example. Right, our next example was the 7 over 3 to the n. Right, so here, again, I recommend we just write out the first few terms so we can see right away what c and r are. Right, so this is going to be, at n equals 0, we're going to get 7. And then the next term, we're going to get 7 over 3. And then the term after that, we're going to get 7 over 3 squared, and so on and so forth. So our common ratio here is the third. That's less than 1, so this converges. Right, so 1/3 is less than 1 in absolute value, so it converges. And the limit is going to be, right, we just go ahead and we apply our formula. Our limit will be it's going to be c over 1 minus r, right? That's using the formula that we had. C is 7. And here we get 1 minus 1/3. So this gives us 7 over 2/3. So that's going to be 21 over 2. And that's the value of our series, right? So our formula allows us to conclude exactly what's going on here. And now let's do one more. Well, we had 2 more examples that we were looking at. Let's look at both of them quickly. Right, so the third example, we had the sum from n equals 2 to infinity of 5 over 2 to the n. And now this one's getting a little tricky, right? This one's a little tricky because we need to identify what c is. And because we don't start at n equals 0, we now need to rearrange our formula so that we see it in the format where we're allowed to use our formula. So let's go ahead and write this as the first few terms, right? This is my recommendation for how to approach this problem. So when we expand this, we start at n equals 2, so we get 5 over 2 squared. Right, so that's going to be 5 over 4. And then afterwards, we're going to get 5 over 8, and then 5 over 16, so on and so forth. right? So this gives us c is 5 over 4. That's fine. And r is equal to 1/2. Right? 1/2 is how you jump from 5/4 to 5/8. It's also how you go from 5/8 to 5/16. And so that's the common ratio is 1/2. And then just applying our formula, right? The formula then gives us that, well, so first of all, the series converges. That the series converges, and that's just because this ratio is less than 1. And the value of the series is going to be c, right? This is c over 1 minus r. That's the formula. And now we just go ahead and plug in what c and r are. Right? So c is going to be, I'm going to write this as 5/4 times that expression. Right? So that's going to be times 1 over 1 minus 1/2. I don't like complicated fractions, so I like to break them up like that when and if I can. Right, and then that gives me, I can put the 5 on top here, and then here I get 1 minus 1/2 is 1/2, and then times 4 is going to give me 2. Right, so that series is converging to 5/2. Okay, so hopefully that's clear. Let's now take a look at our last example with the repeating decimals. Right, so we had this 0.78, 0.78, 78, 78, 78, 78, 78, 78, 78, etc. Right, and then what we saw earlier was this is 78 over 100 plus 78 over 100 squared, etc. So that means that c is 78 over 100, and this common ratio that we have here is going to be 1 over 100. Okay, and conveniently enough, 1 over 100 is less than 1. So that means that this series converges. We already knew that, right? Because we knew that this decimal makes sense, that it's a number. You've known that, I think, since some point in grade school. Maybe not grade school, but anyway, you've known it for a long time that this expression makes you a number, right? So that's what it means to say that expression converges, so that it makes sense as a number. And now, just using our formula, we get, right, that the value is going to be 78 over 100 times 1 over 1 minus r. Okay, r was 1 over 100, so let's go ahead and put that in there. So that's going to give us 78 over 100 times 1 over 99 over 100. Right, multiplying through the denominators. Our denominators, I can say 100 here multiplies by the 99 over 100. This thing gives me 78 over 99. Right, so that's how we can turn a repeating fraction like this into, a repeating decimal like this into a fraction. So that's another use of geometric series.